This is part 2 of the 5.03 review, Factors Affecting Reaction Rates. Many factors, including temperature, concentration, pressure, surface area, and the presence of a catalyst, can change the rate at which a chemical reaction takes place. Objective, describe the factors that can change the rate of a chemical reaction. Remember, changing reaction rates. In general, anything that increases the likelihood that reactant particles will collide will increase the rate of chemical reaction. Increasing the temperature increases the rate of most chemical reactions because the molecules are moving faster. Increasing the concentration, because there's more of them, of one or more of the reactants increases the rate of most chemical reactions. Increasing the surface area, so making the pieces what? Bigger or smaller? Smaller. So increasing the surface area of a solid reactant generally increases the rate of chemical reaction. Increasing the pressure on a reaction in which one or more of the reactants are gases generally increases the rate of a chemical reaction. A catalyst increases the rate of chemical reaction by lowering the reaction's activation energy. A catalyst is a substance that participates in the reaction, so it's an extra chemical, but it's not produced or consumed, in other words, used up during the reaction. That is, it is neither a reactant nor a product. Chemical reactions don't happen at the same rate. Some reactions, such as the explosion that occurs when fire hits a stick of dynamite, are almost instantaneous. Others, such as iron oxidizing to rust, are slower. The conditions under which a chemical reaction occurs can affect its rate. Factors such as temperature, concentration, pressure, surface area, and the presence of a catalyst can all change the rate of chemical reaction. Higher temperatures can speed up the rate of a reaction by making atoms and molecules move faster, which increases the chances that reactants will bump into each other. Having a greater concentration of reactants also increases the chances that the reactants will come together, because there's more of them. Increasing pressure on the gases can also make reactions faster because it forces the gas molecules or atoms closer together, making them more likely to react. For reactions involving solids, a greater surface area increases reaction rate because it exposes more of the atoms or molecules to be able to react, because there are more edges. Finally, the presence of a catalyst, a substance that increases reaction rate without being consumed in a reaction, can provide a faster pathway for reactions to take place. Okay, identify how surface area affects reaction rate. Some antacid tablets used to treat heartburn contain baking soda and citric acid. When dropped into a glass of water, these tablets undergo a chemical reaction and slowly release carbon dioxide gas. A student drops a whole antacid tablet into one container of water and a crushed antacid tablet into another container. Which will react more quickly and why? Hit pause. What's your answer? And of course, it will be the crushed one. Generally, increased surface area corresponds to increased reaction rate. Okay, if you're feeling like, I got this, okay, prove it. Here's a graph. We have percent of reaction completed, and we have the time. Which of these three lines shows two gases reacting under the most pressure? So hit pause, take your time, figure it out, hit play when you're ready. So we have gases, and gases are affected by the pressure. Which one is under the most pressure? I would say the red line, because it's increasing percent of reaction rate completed the fastest. Okay, which one of these has the highest temperature? Hit pause and get your answer. The answer is, again, the red one. Highest temperature, fastest reaction going on, because it has the highest percent of reaction completed in the least amount of time. Okay, so only this much time versus the green one took that much time, and the blue one took a lot of time. Okay, that's it for this one. Go ahead and take your quiz.